Let's start with the point. If you ask a mathematician, a point is a zero-dimensional mathematical object which can be specified in n-dimensional space using n coordinates. A point in mathematics has no geometry or size, but we'll display it as a sphere in the viewport just to be able to see it. The basic geometric structures of higher dimensional spaces, like lines and planes, are built up of an infinite number of points arranged in particular ways. Let's take a look at these structures and see how points are expressed and handled there. Looking at one-dimensional space, we have a single axis, a line containing an infinite number of points. We can express the position of any point with only one coordinate. This coordinate represents the distance from a special point called the origin, which has a coordinate of 0. In MaxScript, an integer or floating point value can be seen as a one-dimensional point where its value expresses the distance to the 0 origin. We can see any point as a one-dimensional vector which has its start at the origin and the end at the point in question. A vector has a direction and length. A vector can be freely translated and remains the same vector as long as its direction and length remain the same. For example, we can translate this vector along the only axis of our one-dimensional space, but the vector itself remains the same. The addition of two floating point numbers can be seen as the addition of the two vectors whose coordinates these numbers represent. For example, if you have a point with coordinates 100 and another point with coordinate 200, the sum would be a point with coordinate 300. Let's define a vector and a second vector. In order to achieve this result, we would translate the second vector so that its starting point is coincident with the ending point of the first vector, and then we connect the beginning of the first vector with the end of the last vector. The result is the sum of the two vectors. A new vector starting, in this case, at the origin and pointing at the point with coordinate 300. If the second vector was minus 200 instead of 200, the result would be minus 100, as we would have subtracted the vector 200 from the vector 100. Basically, we represented the addition of 100 plus 200 in a graphical form. This way of representing vector additions and subtractions is valid for any number of vectors and any number of dimensions. This means that we can add multiple vectors by taking the beginning of the next operand and placing it at the end of the previous operand, and in the end connecting the beginning of the first operand with the end of the last operand. We can also multiply a vector with a scalar. A scalar would be any integer or floating point number in MaxScript. The result is a new vector whose coordinates have been multiplied with a scalar. In one-dimensional space there is only one coordinate, so we would multiply the x coordinate with the scalar.